Hello and welcome to another Unreal Engine 5 video. In this video we'll remake the helicopter blueprint. We'll make it with a better method. This method will be applicable to Unreal Engine 4 and 5. I will start with a blank project and name it helicopter project, and we do not need the starter content. Now we create our project. I'm doing a voiceover because the audio was messed up for the recording, so you won't hear the keyboard and the mouse. Now I will add the vigilante content, the helicopter, the KA-52. And this video will be slightly long, for 1 hour, and another video I will make to make the animation of the helicopter, like the folding gear, and also maybe some other things, like maybe I'll continue the series. Now here in the project I'm making a new folder for the blueprints and add a pawn blueprint for the helicopter and call it the BP underscore helicopter. Then in the blueprint we need skeletal mesh, spring arm and camera. First we add the skeletal mesh, then we add the spring arm, attach it to the skeletal mesh, then the camera also attach it to the spring arm. For the skeletal mesh we use the KA-52 mesh, like I said earlier, and for the spring arm I will adjust the position of the spring arm. We'll set the Z value for the location to 50 or 200. I will set it to 200. Then and the spring arm length 2500 units, and the socket offset also I will add to it 300 units. Let's compile. Also add some rotation to the camera. We'll add -5 degrees on the y-axis. Now after we compile, I will activate the lag, the camera lag, to add some realistic feel to the helicopter, because without the lag it will look weird and will make the experience unpleasant. Now for the skeletal mesh, first we should I will delete some things that I do not need in the vigilante content, like the blueprint and the levels. I'm checking the files, what I want to delete. Now I delete the blueprint, delete everything else, like the levels and the blueprint for the helicopter. Now also I will delete the animation blueprint and the blueprint for the helicopter and make a new animation blueprint. We do not need these nodes for the helicopter. We will make our own nodes, our own logic. So let's delete the animation blueprint. Now right click on the skeletal mesh and make a new animation blueprint. Now for the physics asset, we need to delete all the bodies and remake the root bone, remake the bodies for the root bone and the wheels. The root bone here is cog joints. I'll firstly make it with multi-convex hull, then search for the wheels, find the front wheel and the rear wheels, and change the primitive type to sphere, and add the bodies. Then we set everything to simulate it, the root and the wheels. Now set the root to simulate it and the wheels also to simulate it. Now here on the right lower left corner we change the physics constraint for the wheels. We lock everything in the motion except the Z motion. We need it to be limited, and we will set the limit to 5 because we need them to go up and down and act like they have suspension. Also the twist, we need to limit everything. The swing and the twist motion would not need the twist now. Maybe in the future we will need them and we will change them accordingly, but yeah, right now we do not need them. And now we are finished with the physics assets, and let's simulate and see. Now it's behaving normally. The collision of the wheels is proper. So let's go back to the blueprint, helicopter blueprint, and set the animation blueprint. Now we need the player controller and we need the game mode class. For the player controller we needed to make the enhanced input settings. In this like I said, this tutorial works for Unreal Engine 4 and 5, but the only difference is that in this Unreal Engine 5 we will make the enhanced input setting, but in Unreal Engine 4 you can use the default input settings, which will work fine. Now we will first save the level, so that when we reopen our project the level we will open the level that we saved and not make new level every time. For the project settings, change the maps and go to the maps and mods, and change the game mode to helicopter game mode, and the map to the map that we saved, and we called it map. And also set in the world setting, set the game mode override to helicopter, the helicopter game mode. Now let's test the helicopter. Like you see, it's suspended in the air because it is not simulated. Need to check simulate physics here in the animation, the skeletal mesh, and it will also be suspended because we forgot about the collision. We need to set the collision of the skeletal mesh. And now we set the collision to custom. Here we see there is no collision, so we change it to custom. Change it to collision enabled query and physics, and the object type will set it to pawn, and also make everything to block. Now when we test, you see now it's simulating physics, but we see that the wheels sink in the floor because we need to set the mass of the wheels. First I set the CCD, but they will still sink, so later in the video I will set the mass for the wheels as 100 kg for each wheel. Now you see that it worked, but sometimes it doesn't work, so we will come back to this later in this video. Now we need to make the input. I'll start making the input now. First let's make a new folder and name it input. For the input we need two things: input action and input context mapping, or input mapping context. First we make the context, input mapping context, called IMC helicopter. Then we also go right click and also go to input and use input action. IA, call it. First we will start with the turn, which will open the input action. We'll change the value type to axis 1D because we want the axis value. It will help us setting the pitch and the yaw of the helicopter. Also we need another one. We duplicate the turn. We need the pitch. We will make 4: the turn, pitch, and the thrust, and the tilt sideways. All should be axis values. All will be set to axis value, axis 1D. Like I said, the only difference between Unreal Engine 4 and 5 in this video is the input settings. In the Unreal Engine 4 you can use the default input setting. You will not have any problems following this tutorial. Now we set the tilt input action. Now we should go to the context mapping to set the keys for the keyboard. We will start by adding mapping. Start with the pitch. The pitch should be mouse Y. You will be search for mouse Y. Do not need any modifiers here, or I will make a negate modifier to reverse the values, to make it that when you pull the mouse downward, the helicopter nose goes down, and when you pull it up, the helicopter nose goes up. Now the second one, we make the thrust. The thrust, we will use the left shift for going up and the left control for going down. So we need two buttons. First one, like I said, the left shift. Second one is the left control. And for the second one, the left control, we will add a modifier, which is the negate modifier. to make the left control give us negative value. Now we'll make the tilt the same as the above. We need two keys, two buttons. The right will be the D button, D keyboard button, and the left will be the A button. Now we set the A button keyboard. Also the A button, we should set the modifier to negate. And the turn. The turn we use the mouse X for the horizontal axis and mouse Y for the vertical axis. And the mouse Y, I will add another modifier which is the dead zone. It will give me smooth movement because my mouse is giving some weird values. When I go up and down, it also give us left and right movement. So I think the problem is in my mouse, so I only made a dead zone for me. If you have no problems, you do not need it. Now let's go back to the player controller. For the helicopter, we need to set the context mapping here. We need enhanced input local player subsystem, and we drag from the enhanced input subsystem. We add mapping context. Mapping context will be IMC helicopter. Now we do not need the game mode and also do not need the player controller. Now let's start with the helicopter. We don't need the overlap, we need only the begin play and the event tick. Now I will call the input action, the pitch and the turn, the thrust and the tilt, and we will start with the thrust, making the thrust logic. The thrust logic will depend on adding force to the skeletal mesh of the pawn. This force will make the helicopter go up and down. We will need to apply this force only to the z-axis of the helicopter, and also we need this z-axis change with the helicopter direction, and if it rotates forward or backward, the thrust will remain to the local z-axis of the helicopter. So first we start by setting the action value into a variable, because we need the thrust to update on the tick, because you need continuous update to keep the force value and to change it according to the elevation of the helicopter. Now after we set the value, we start by making custom event, call it set thrust, and we start by add force. First we need to get the skeletal mesh and add force. Here we connect the execution pins. Now I will leave this acceleration change to unchecked, because I want the weight of the helicopter to affect the way it moves. So with increasing weight, we need more force applied to the helicopter. And now we need to promote the bone name to a variable. Here we need the helicopter root bone, which is the cog joint. This bone will receive the force, and it will change according to its direction. Now we put the name of the bone in the helicopter root variable that we made earlier. Like I said, I will leave this acceleration change unchecked because I need the helicopter weight affect the movement of the helicopter. Like if we have a heavy helicopter, big helicopter be slower than lighter helicopters. And also because we need this blueprint to be like a base blueprint for any helicopter that we want to make in the future. We only need to change some values like the weight, the engine power. Here we need the socket transform. The socket name is the same socket bone that we specified for the root. And also we need to transform direction. Like I said, we need the force applied to the z-axis of the to the local z-axis of the helicopter or of the root bone, so that when the helicopter change direction or change the rotation of the helicopter, when it tilts forward, it will move forward because the axis will be tilted to the back and the force will be going backward, so the helicopter will move forward. And now we need to calculate the force. First we need to apply the force to the z value, like I said, z direction. We'll start with make variables, and the variable we will multiply it by the thrust axis. Now we will drag a multiply node, multiply operator. We will add first we'll set the weight of the helicopter and the physics assets. We go to the physics assets and set the mass. I will set it to 10,000 kilos for this. Yes, 10,000 kilos. We multiply the thrust axis by here we need large numbers, like maybe 1 million, 10 million. I will start with 1 million and we will test. Set thrust. Now let's test. As you see, it will be a very powerful engine, so we need to decrease the force. This will be like, I think, 10 million. I think is reasonable. Now you see the helicopter is going up, but still we need more force. It is unstable, so we'll make it 5 million. First we'll promote it to a variable. Let's call it engine power, this new variable, float. Now like I said, we should increase the engine power. Let's first comment this custom event. Comment is very helpful because you will make the blueprint organized, and when you return back you will know what's going on with the nodes, and you will not have hard time understanding the nodes and the function of the blueprint. So keeping the blueprint organized is a good practice that you need to get used to. Now I think I will make the pitch. Also, let's add the custom event. So we'll make call it set pitch or maintain height. Sorry, I forgot. We'll start with maintain height because we want the helicopter to stay in the air when we release the thrust button. So we will change the input, the thrust axis, or we will change the value of the thrust according to the velocity of the helicopter, and it will depend on the z axis of the velocity, because we don't need the forward and backward, only the z axis, which represents the speed that the helicopter going up and down. Now we get a map range clamped. This works by it monitors a value you enter and check it against a range of two values, minimum and maximum range, and it gives you an output you set, an output range also you set in these values. So I will start with 100. So the in range A will give you the out range A. So the in range A 100, and the out range I will make it negative, because if the helicopter is going up, I want it to go down, so I want the negative value applied to the thrust. And also if the helicopter is going down, I want it to go up, so I will apply a positive value to the thrust. And this will help keep the helicopter maintain its height when we release the thrust button. Here we set the thrust, but we need first to add an input to the custom event. So here, go back to the custom event of the set thrust. Add an input variable, call it input, and make it a float. And connect the output from the map range to the input, and the thrust axis we will also connect to the input. Here we need to connect the input. First let's comment the maintain height nodes. Maintain, I forgot to type height. Anyway, now the tick function, we call the maintain height node. We need to change things about the node, so we need to add a check if the input value is 0 or more than or less than 0. If it is 0, we will maintain the thrust by calling the set height or set thrust, and if the value is more or is not equal to 0, which means we are pressing the button for the thrust, and we need to either go up or down. So we delete the set thrust in the controls. Now we test it. We go up, but still it doesn't go up that well, so we need to increase the power that we are applying to the helicopter. Now the engine power, we'll increase it, make it like 50 million. Here the helicopter will fly well, but still does not maintain height because we forgot to add the input here. Now we test it. Like you see, the helicopter is maintaining height when we go up or down, but it's going up fast, so we need to change the values. And like you saw, the helicopter was going down, doesn't maintain height, so we increase the value for the map range to increase the force for going up. Now we set the height and the thrust. We start by adding the we need to make the pitch and the tilt. We'll start by making the pitch. The pitch will handle it by first we need to add an input to the custom event and call it input, and get the skeletal mesh, and like I said, we handle it by adding torque to the skeletal mesh. The torque will rotate the helicopter mesh according to the axis of the root bone that we specified. And here I will make the acceleration change to true, because I do not want the weight of the helicopter to affect the turning and the other movements of the helicopter. But if you want, you can leave it unticked, but you will need significantly higher values to set in the torque. Here we need to make vector and connect the input to the y axis. Like I said, because the acceleration change is true, so we don't need big values. So the value of the input axis, which is between 1 and -1, is enough to rotate the helicopter. Here I also forgot to implement the custom event. So here we implement the event and connect the action value to the input, and we test it. Like you see, the pitch is working fine. It's going up the helicopter, but still very fast. We'll make it right, and we'll make the the speed of the pitch increasing, we will change it and making it smooth with f interrupt node. Now we'll add the turn after this. First we'll make a branch. This because you saw the helicopter was unstable, so this branch will help us to stabilize the helicopter, and by checking if the input is 0. So if the input is 0, we will not apply any force or any torque to the helicopter. Sure. So in the true execution pin, we leave the torque values to 0, and in the false we apply our force, and when we test it, you will see that it's significantly better controlled the helicopter. Now I'm talking about the how we implemented the pitch by adding the torque in the radians. So now let's test. When we test, like you see, the helicopter is smoothly moving forward and backward, and we do not face any problems with the pitch of the helicopter. Let's comment now. Organization is very important, because when you have big projects and you go back to them, you will see you'll have very hard time reading the notes. Now we need to make the helicopter more stable and avoid jerking movement. We set the angular damping. We increase the damping to 2 to make the rotation movement of the helicopter make it smooth and feels like it's a heavy thing or a heavy vehicle, and also it will smooth out the movement of the helicopter. Also, we want to set the linear damping of the helicopter to smooth out the going up and down of the helicopter without changing the values of the thrust. Now when we test, you see that it's going up smoothly. Still fast. We'll fix it later in this video. Now you see that the pitch is smoother and the helicopter is flying well, but still going up and down very fast. But I will fix it later in this video. Now we need to make the turn. We duplicate the pitch values and change the custom event to turn. We and also need to change the input to the x axis, or the z, sorry, the x for the tilt, z axis for the turn. And also comment these nodes, set the turn value. Do not here I did not forget about implementing the function and the input settings and the input. Also the tilt, the same we should make. Also duplicate the turn. Also name it the tilt to set tilt, and we changed it from the Z value to the X value. But as you will see, we will face some problem when we test. Set tilt, and also implement the function. Now to test the helicopter. Now it's going up and the pitch is working fine. The turn also working fine, but as you see the tilt, when I'm pressing the left and right, the helicopter is going up and down because we forgot something in the tilt, which is we needed the tilt to take in account the transform of the helicopter. So we need to add a get transform node, and also set direction, transform direction, to make the helicopter take into account the transform of the skeletal mesh. Because if you do not make this, the values will be applied to the x-axis regardless of the direction, to the original x-axis, or the original x-axis. So when the helicopter turns to left, the axis will be like you see here. When it's facing forward in the original position, the tilt is fine, but when we turn to the left, it's changing. Now it's going forward and backward. Here it's going in the reverse way when you turn. So we need to take into account the transform of the skeletal mesh. So we need to, like I said, get socket transform, and the socket is the root socket of the helicopter. The same root socket of the helicopter, and here we need to transform direction. Now we connect the input axis to the direction, to the x direction. Now let's test. Now the tilt is working fine. When we turn the helicopter left and right, also it's working here fine, and here also it's working fine. Nothing wrong with it. I will apply the same thing to the turn and the pitch just to be safe, because sometimes we'll face problems with this with the pitch value. Here the like I said, the inputs were reversed. I don't know why, but we should multiply the input by -1. Now I'm testing the input values to see if it is right. Like when I press D, it's giving plus, and when I press A, giving minus, but it's still reversed. I think the torque, it's good because of the transform direction. So we multiply it by -1 to solve this problem. Now like I said, I will make the same thing to the pitch to be safe, because sometimes the control is it doesn't control well. So we need also to copy and duplicate the get transform and transform direction and connect the input action to the y value of the direction. Now it's working fine, going up and down, and the pitch is working well, and the tilt and the turn also working well. Now let's add the finter node to smooth out the thrust input. Look for the finter 2. We put this variable in the target, and we promote the return to a variable, call it current thrust. The current value here, we use the current thrust. For the delta time, we need delta world delta seconds. For the interrupt speed, I will use 0.3. It will give us a smooth transition of the thrust. And do not forget to connect this output, the variable, to the direction Z. Now you see it's going up smoothly, and when you release the button it will continue be in the air, and when we go down it goes down also smoothly. But you see that when I try to land, it goes up when I release the button. So we need to decrease the value in the map range. First delete the preset ring, then go here to the maintain height and change the out range B to 1.5. After that, you see that it's when we go up and try to go down, it's going down smoothly, but still very fast, like you will see, still fast. Still try to land. We go here because the wheels sunk, so we go to the physics asset and we increase set the mass of the wheels to 100 to make them to avoid being sunk to the floor. Now after we set the wheels, now the helicopter, the wheels function properly and is not sink to the floor. Now the helicopter is working fine, go forward, backward, down, the pitch is working, but we still need to do something about the landing speed. So here we go to the input, go to the input, thrust axis, we clamp the minimum to 0.25 and the maximum to 1. I will start with 0.5, minus 0.5, and like you see I will test it, and it's a bit better but still fast. So we decrease it to minus 0.25. Now you see in the test it's going down smoothly and will not hit the ground very fast, and you can change it according to your liking. For me, I prefer a smooth landing like this. So what's left, we made the movement of the helicopter. It's working fine. Now what's left is the rotation of the rotors. Rotation of the rotors of the helicopter. Here, first we need to set the rotation speed. First we need a reference to the helicopter, to helicopter blueprint, cast to BP helicopter. Then we need the begin play. We need to cast only one begin play. Then promote the helicopter to a variable. And here below we need to check the helicopter blueprint is valid before we do anything in the animation blueprint. Here we will add a variable, the rotor speed, and make it as a float. We'll change it to a float. Seems like I'm talking too much. The we'll make the rotor speed change with the helicopter thrust. So if we are pressing the thrust button, it will go, the speed will increase of the rotors, and it will decrease when we press the going down. Here I'm making a mistake. I should add the rotor speed to the multiplier. Here I will multiply the rotor speed by the input thrust axis, but it will not work because I need to multiply the thrust axis by the something constant and then add it to the rotor speed. But here I'm making this mistake. Like I said, first we clamp the float. Here we need to add, first we need to make a state machine, a new state machine. Now we make state machine. And we save it as the idle pose. Now we open the state machine. We need here a state, new state, and state. We call it idle. And we need an idle animation. We do not have an idle animation in the generative content, so we need to record a new animation. We can record it here in the animation blueprint. Like we press the record button, and now we press the record button, save the animation in a new folder. Let's call it animation, and name it as idle animation or helicopter idle. Press OK and wait for 1 to 2 seconds, then stop. get this new animation and put it here in the output animation pose. Then we go back to the anime graph. Here we call the idle pose, use cache pose idle. Then we need to get the modify transform bone. Here it doesn't work because this is local. This is still doesn't work because, like I said, this is the cache pose is local and this is component pose, so it will transform to component. Here we need first we do not need the translation and we do not need the scale, and for the rotation mode we change it to add to existing, and this to parent rotation space to parent bone space. And we need to split this pin, and we need to set the first duplicate this node because we need 2 rotors. Now we look for the rotor bone. Let's find it here in the animation in the skeletal mesh. Rotor. The rotor is rotor main, rotor base. This rotates the everything. We need the rotor 1 main, this one, and the other one is rotor 2 main joint. Here we type rotor. Like I said, we need the rotor 1 main and the rotor 2 main. And we apply the float that we have to the Z rotation. We get the rotor. For the first one we'll make it positive, for the second one we'll multiply it by -1 because the rotors rotate in an opposite direction. Here it doesn't work because, as I said, I made a mistake. Here we need to multiply the thrust axis by the constant float, which is here is 10. And we will make it 10 and we will promote it to a variable and call it rotor speed rate or rate of rotation. Now, like you see, when we press the thrust, they go faster, and when we press the descend button or we leave the button, they will become slower. As I think they need more work because we do not want them to decrease the speed significantly when we release the button. Only when we press the go down button. We will change it in future videos.